Good afternoon, everyone. We are going to start today's session, and today we will be starting from the chi-square goodness of it, which we did on Saturday also, but we said that we'll again repeat it on Monday because there were few participants who requested for Monday. So goodness of it, let me go to day 1. So basically, goodness of it, we also call it as a one sample chi-square test. Why we call it as a one sample? Because here we only take one sample and we test the proportion of that sample against some known proportion or any hypothesized proportion. So we'll see the basic concepts of chi-square goodness of fit. Then we'll see what are the research questions for which we need to answer. Is the output? Let me check. Is it okay? Volume. Then assumptions and hypothesis, commands and interpretation. Oh, I'm sorry, I think I have not shared my screen. Will you give me the sharing right? So we'll see the basic concepts, the research questions for which we need this chi-square test of goodness of fit, the assumptions and the hypothesis, the commands and interpretation, and then I'll summarize the command before we go to the breakout room. So, like we in a single sample, we know about the distribution of cases, and that may be a single categorical variable. Let's say if it is a hypertension, what proportion of people in our sample are hypertensive? If hypothesis is something like that, which we started on that day, that NFHS says that 22% of the people of India are hypertensive, and in our sample it came to be 18%. And I just want to check whether this proportion is how this is different from the national value according to the NFHS data. So this is my known value, and known will always be unequal because here the non-hypertensive will be the rest of the people, like rest 80%, and the hypertensive will 78%, and hypertensive will be 22%. But if I don't know that, then what this software or any software does, that it takes the unknown proportion as equal proportion. Means if the categorical variable is having 3 levels, it will take 3 like different 33.3, 33.3, and 33.3%. If it is 4, like in case of a ABO blood group, so it will take each blood group the proportion as 25% if that proportion is not available. So then through this chi-square goodness of it, we check for this single sample, and again it is a non-parametric test like all other chi-square tests. So for example, if I know that the prevalence of obesity in Indian children is 5%, but when I did my study, I expect that 18 out of 90 children will be the case of obesity. If that is not the case, but there are 25 cases of obesity in my sample, and this number is significantly higher than the expected. So my research, so what are the various research questions for which we need this chi-square test of like one sample chi-square test? So if my research question is, like if I want to know whether the proportion of BMI of the MBBS students in my college, is it different from the national proportion? National means you can take like in various age groups. So if I know about my BMI proportion of BMI categories, like maybe I have defined the category as obese, overweight, and normal. Or if I want to know about the surgical site infection rate, what is the surgical, like how my surgical, my unit is different from the overall hospital in context of this surgical site infection rate. if that is reported at institute level, or if what is the passing percentage, like let's say AIMS Patna, if the passing percentage of student is 80% or 90%, how it is different from any other institute. Let's say you can take AIMS Delhi or any other institute. So any reference which you want to take, you can take that, and then you can compare whether it is significantly different, or like there is no significant difference between this passing percentage. So for all these type of research question, what we have observed, that there is a single variable in all these cases. The levels of these variables might vary. That means it can be a binomial variable having only two levels, or it can be a polytomous variable which has got more than two levels, like category of BMI or blood grouping, where the blood group has got four levels, or the category of BMI is having three levels. Then this chi-square test of goodness of fit, which is also known as the one sample chi-square test, is the appropriate statistical test. So there are basically three assumptions. The first assumption is like there should be one categorical variable. And we know that we have seen that because it is called one sample goodness of fit or one sample chi-square test, only one sample is required. Second is there should be independence of observation. We talked about independence of observation means like if you have counted one individual once, you will not be count the same individual again in that group. Or the people whom you are recruiting, they should not be related. Like they should not be husband and wife, or they should not be twins, or related means siblings also. If your research question does not involve study on such study participants. And then the expected frequency in each cell should be at least 5. And we know about the expected frequency. We calculated expected frequency that day. We have seen, means we will do again that in the breakout room today, because we assume that if the null hypothesis is true and we apply the same proportion to the individual group, then what is the frequency that is known as the expected frequency? So you should click the expected frequency and see how it is, like whether the frequency in each cell is more than 5 or not. So it compares the observed frequencies in the categories with the hypothesized frequencies. So we may have two conditions. Either the hypothesized frequency or the hypothesized proportion is available. Like in case of, let's say this hypertension, I have this hypothesized proportion. Or if it is not available, then it takes all the categories as an equal proportion. For example, if I have recruited 100 individuals in my study and I want to know whether the normal, overweight or obese category, are they different or they are similar? And I have, like, this is my hypothesized proportion. So in my hypothesized proportion, 50% of the children are normal, 40% are overweight, and 10% obese. If this is not available, then what it does? It takes all these three categories. Whatever is the number of category, it divides that into 3 or 4 levels depending on the number of categories, and it considers that the proportions are equal, and then it calculates the, basically this is needed for the calculation of expected. So it calculates the expected frequency based on the same. So let's say now we will go to the JAMOV sheet. This is all, and remove. I've removed all the analysis and I'll start afresh. So this is the frequency. This is JAMOV interface. We are now very familiar with this interface, and this is the frequency. So I'll click on this frequency, and you will click on this chi-square in test of this goodness of it. This we have seen, test of two proportion. I will revise this once again before we go to the breakout room. And this is the goodness of it. So I click this goodness of it, and let's say if I want to compare the blood group. So blood group is having 4 levels. So this is the blood group. I'll move this blood group here. and I can see this expected frequency. So if you don't enter anything here, it takes all the proportion as 25, 25, but I have my national proportion. So A is 35%. So I'll enter 35 here. It's written ratio, but even if you enter this percentage, it automatically converts that into ratio. B is 10%. So B comes here. It is 10%. Then O is 50%. So O is 50%. And then AB is 5%. AB is 5%. So you can check like 50, 40, and 100%. So, and you can check the expected cell count. So you can, if you click that expected cell count, you can see like 59 is the expected, 8.5, 17, and 85. So in each cell, the expected count is more than 5. So that assumption I have checked, and then I can see like, yes, it is significant. Like the proportion of individual in my group, it is definitely different, like observed is significantly different than the expected. So I again said that for table, you don't click on this expected count and you just show this. Here, I guess this is your proportion. It automatically gives. So 28%, 6%, this is observed, 33 and 33. So this is because the number is equal. So in our case, B and O are having equal proportion, and this is different from the national average. National says like B as 10, whereas in our case it is 33. National say O as 50, whereas in our case it is not much, but it is 50, this 33. So it is different than the national, lower than that. So this, then how to write the interpretation? So interpretation you can write just comparing that in your case, the proportion of the various levels of the various blood group was significantly different from the national proportion. And then you can show one of the two figure. It's not necessary to write each and every figure. Yes, if you are doing a thesis and writing your thesis report, then you may need to give all the values. Like you can write this 48 and difference 35 and 28. So you can write this difference of 7% in A, then difference this AB is 6%, and here it is 10%. So you can write 4% difference in AB, and in case of a B, it is higher, means 33% is there, whereas national is your 10%. So 23% high. So that you can write here. Or if you don't want to use national figure and if you want to use some other study, if you want to compare with some other study, you can give the figure of that study as a known population. Even like you can use any data which your ward or in your unit it has, or any historical data set is there. And if you want to see or conclude that your data is different from that, that also can be done. So this is the chi-square single proportion, chi-square test of single proportion. Again, coming to the other, just to demonstrate two other types of chi-square, which we did that day. So you will go to this frequency, click on this chi-square test of association, and then you can like see if I see the question. So maybe if I see the gender and anxiety. So maybe I will enter. We discussed that in row we move independent variable and in column we move dependent. So anxiety, it is the anxiety category. So anxiety I have entered here, and then you have to check for the assumptions. So for assumptions, you go click on the expected in this cell, go and click on this percentage, row and expected count. So you can see like expected count is 11, 51, 86 and 20. So it is more than the 5, and then you can see the percentage. And after you have checked for the assumption, you will uncheck this. Why? Because in table, we don't write expected frequency. Many times you see that PGs, what they do, they will click this write table, write this thing, copy, and they paste it as such. But no, this you need to write this in the bracket. This percentage should be in the bracket. It will not be like the format which you see here. But you see that there is no significant difference because p value is 0.954, which is not less than 0.05. So this difference in the category, and then how will you this interpret? So you can see like in females 19. Why? Because almost same proportion was there. 19% of the male and 19%, like it is, percentages are all equal, you can see 81. And this is the real data which we have collected. Maybe the sample was diverse, but you can see exactly, that's why you can see the chi-square value is 0, because the proportion are exactly same. And if you see total, so total is also 80, 81 and 19. If I click on expected, and I don't click the percentage, you can see there's a very minimal difference between all expected, like 51 and 51.4, 87 and 86.86, almost 87, similarly 20.14. So value, the difference is so less, that's why if you see in proportion, it is the same proportion. So that's why the value of chi-square is 0 here. And so if the value of chi-square is not significant, there's no point clicking on this effect size, because effect size will be commented only when there is a statistical significance. So this was not significant, then I can see the gender and hypertension. So maybe I will move this to here and I can check for the hypertension. So this was anxiety, hypertension, this we have formed, this was the hypertension. So yes, hypertension, it is significant, 0.001, gender and hypertension. And you can check first for the expected count before clicking on percentage, because assumption needs to be checked. So you can see expected is 21.86, 29, 11, 19, 50 and 37. So it is more than 5. Now you can uncheck expected and you can check this row percentage, and then you can write the interpretation. So you can see like in case of female, 6% were hypertensive, whereas in case of men, 25%, almost 4 times. So proportion of hypertension, what is significant to write here? That the proportion of hypertension in men were 4 times higher than the women. So that's why you can see that again, if this pre-hypertensive also, that is more than more in men, and normal is almost twice in women. So these findings you can write, and then you can write, you should write about the assumptions also. So you will write that 3/2 table, all the expected cell frequencies were more than 5, and that's why chi-square test of association was applied. The proportion of hypertensives in male was 4 times as compared to female. In the bracket, you can write 25% versus 6%. And the value of chi-square, you can also write this normotensive, and then you can write which was significant with a chi-square value of 19.61. At 2 degree of freedom, the p-value was less than 0.05. So this is how you will write the interpretation. So Dr. Vignesh is asking, ma'am, when can we use the effect size measures mentioned under ordinal? Okay, this is generally used when you have to see the association between the ordinal variable, you can use that. Like let's say, if I enter hypertension and hypertension grade and PHQ score grade, like let me This is the new one, na? It is already there. So hypertension, I'll move to, if my this thing is hypertension leads to probably higher depression. So hypertension grade and then PHQ pre.
इसको कन्वर्ट करना पड़ेगा ऑर्डिनल में.
No, that is in ordinal, na?
हाइपरटेंशन ग्रेड ऑर्डिनल नहीं इस एक्सरसाइज के लिए.
No, उसको तो I will go, you can go to the data, go to this variable. This was there. So normotensive pre, so it is an ordinal, but you have to select ordinal. So make this as an ordinal. And again, you can go and this PHQ, PHQ, you can see the difference, what difference it does. The value of chi-square will not change. So this was a PHQ, just a second. So this was a PHQ category, like normal, mild, moderate, and severe. So these two both are the ordinal one. So you can go to this PHQ category in the column, and in the row you can write this hypertension grade, and then first see the value of chi-square. So value of chi-square is not significant. So that's why you will not check for effect size. And here you will see, like, you cannot go for, because assumptions should be satisfied. So if I check for this count, expected count, let's uncheck this and check this. So now you can see the expected count. So there are, like, here the count is 2.43 expected. Here the count is less than 5. Here the count is less than 5. So in 3 of the cells, the count is less than 5. And in one of the cell, it is observed, not expected. So again, I think you should not, because there are small numbers in these cells. So probably let's see some other variable where you can find. So in such cases, just assume that it is significant, and then you can go for, like, let's say, for ordinal, generally we use this Kendall tau. Kendall tau is used when one is ordinal and other is probably the this thing. So this you can click and it will give you the value. But this is done when the scales are like ordinal. But again, you see that many times what people do, because in ordinal, if the sample size is less, and if the number is like it is not satisfying the assumption, then people treat the ordinal as nominal, and then they go for the chi-square. So this, since there was a two category, so this was the use. So is it okay? So Dr. Tilip is asking, explain the percentage within row, or percentage which is more appropriate when we do the description in the table. Okay. So percentage, generally, if you go by this, you first have to identify you want to explain what. So like we said that there is a dependent variable and there is an independent variable. What do you mean by dependent and independent? Independent is something, the effect of which you want to see on the dependent, right? Let's say screen time, or like we just, we have seen that the commuting time and gender. So if you want to see the effect of gender on commuting time, and if you are moving the gender variable in the row, so you will always see the row percentage. Okay. If if you're not able to identify the dependent and independent variable, okay, many times it may happen that there are two variables and you're not sure, like you want to see the effect of, but that you have to do, because then only you can explain. Let's say now if I say like in case of a diabetes and hypertension, right? So I want to see the effect of diabetes on hypertension or hypertension on diabetes, dependent on that. So in that case, the variable which you move in row. So what we do, we always move the variable, the effect of which we want to see on what. So that outcome means that outcome variable will be your what? It will be your dependent variable. So in the case if your research question is like seeing the outcome variable, let's say it is diabetes. So I'll move this diabetes status. I want to see the effect of diabetes on hypertension. So hypertension is my dependent variable. So I have moved diabetes here in row and hypertension grade here in the column. So in this case, I want to see the association, means like association between the diabetes and hypertension grade. And then you can see like if I have just written the percentage in row. So if I explain this, then what will I say here? That then I will say that people who were not having diabetes, the percentage are like this. So 27% were hypertensive in non-diabetic and 67% were hypertensive. Do you want to say something?
16%.
Okay, sorry. 16% were hypertensive in the non-diabetic and 67% were hypertensive in diabetic. Okay. But if I want to see the other way around, means if I want to comment like in normotensive, or if I want to comment like in hypertensives, how many of them were diabetic? In that case, what I will be doing? Then I will be clicking on this column percentage. I will uncheck this. Now, how will I interpret? So I will say now that in the people who are, so now I will see my percentage like this. Because now this is 100%. See, so I will say that 13% of hypertensives were diabetic, whereas 87% of hypertensives were non-diabetic. Similarly, I'll start taking this pre-hypertensive category. So I'll first explain the hypertensive, then I'll talk about this pre-hypertensive. And I'll say that 1% of the pre-hypertensives were diabetic, whereas 99% were non-diabetic. Similarly, if I want to comment on normotensive, so I'll say that 2% of the normotensives were diabetic and rest 98% were non-diabetic. So it depends, like you want to tell the percentage, means association, and then again you have to identify which is the dependent and which is the independent. So traditionally what we do, if you just go by this, that you move the dependent variable to the column, then normally there is no need of taking the column percentage. Why? Because you have moved your dependent variable to column, so you always click on row percentage. You can do that. But if you don't want to go by this moving the dependent variable in column, then you have to see like you want to start with which group. Do you want to start with hypertensive or you want to start with diabetic? And similarly, you can click on the column percentage or row percentage. But whatever you do, the value of chi-square and significance level, and in this case, you can see like since it is this thing, you can click on this phi and Kramer V, and you can see that value of it is again the value of chi-square is 9.8 and 0.007 and Kramer V is 0.24. If you click on row percentage, then also the value of chi-square will be 9.8, p-value will be 0.001 and Kramer will be 0.24. So it is not going to make any difference of overall chi-square or p-value or Kramer V. It is just the percentage which you are going to explain in the table. Do you want to explain the percentage of diabetic in pre-hypertensives, or do you want to tell the percentage of hypertensives in diabetic. Did you get it? I don't know whose question was this.
Philip.
Philip, have you understood? Okay. And can I see another question? Akash. Okay, Akash, Kendall Tau is, I will tell you that also. Before that, Dr. Sundara Cholan is asking what should be done if it is less than 5 in expected cell. So in that case, you can merge the category, right?
Fisher.
So like Fisher exact test can only be applied if it is a 2 by 2 table. So in this case, since there are 3 categories. So what you can do, you can merge these 2 category like hypertensive, but again you have to see. Here, if you see the number, hypertensives are already 4. So even if you merge pre-hypertensives and normotensives, so you can do like normotensive and non-normotensive. So you can merge pre-hypertensive and hypertensive, but again, there should be some rationale of merging. Like if you merge pre-hypertensive and hypertension, then it is not going to make a difference. Why? Because hypertension is a diseased one, and you cannot, something which is preclinical, you cannot make it clinical by merging the two. So in this case, probably since it is 4, and if I see the expected cell count, just a sec. Let me click that because that will, okay, this is, again, I'll uncheck that. So you can see here, like, yes, since the proportion of diabetes were very less, you can see there were only 6 people out of 170 who were diabetic. So since this is not a true data, but yes, of course, in such cases, you can merge the category. Or you can, after merging also, if the cell count is coming less than 5, then you can apply this test of Fisher exact test, because Fisher exact test can be applied for 2 by 2 table only. This one, this you can click Fisher exact. In case of a n by n table, if the count, and again count we say like in 80% of the cell. Even if in 1 or 2 cell, if the expected count is less than 5, then that is okay. Because in this case, you can see there are how many cells? 6 cells. So 80% of 6 will be, let's say 4. So 4 you can see here. But again, it is not having 4 also because 2.89, 2.8. So I will merge the 2 category. And then after merging, I will merge this normotensive and pre-hypertensive. So it will be like 1 and 1, 2, and then 58 plus 79. And then I'll take out the chi-square value. Okay, Dr. Sundara?
Ma'am, but then there would be less than 5 value would be there in 50% of the cells. If it is, then we'll get a 2 by 2 table if we are merging normotensive and
But in
prehypertensive.
that case, you can go for Fisher exact test.
Okay.
Because Fisher exact test is for 2 by 2. So even if you merge it and the count is less than 5, you have one option.
Okay. Thank you, ma'am.
And anything else? Akash is saying Kendall Tau. So Akash, Kendall Tau is basically for the ordinal scale. And Kendall Tau is when at least one is binomial and other is ordinal. So like diabetes and hypertension, again, this can be there. So if you click instead of phi and Kramer V, you can click this Kendall Tau also. And this also gives you the this effect. So it says that it gives you the value of T, and it says that this association. Rather, you see that this is basically this Kendall Tau is for association. So it says that yes, its value is, you can see that value of Kendall Tau is 0.16. It is not very high because again, it is something like correlation. So that's why you see that correlation is less, so that effect size is not that high. But yes, if you see this, the value of Kendall Tau B, and that is done basically when there is one is ordinal and the other is binomial or the continuous. But in this case, since the chi-square cannot be applied on continuous, so we take it one as a binomial, another as ordinal. And then instead of this phi and Kramer V, you can go for this Kendall tau. Or even if you click this, you can see that value is 0.24. This is also not very significant, but generally in chi-square, the effect size we explain with the Kramer V. This Kendall tau is mostly, you will see, this option is here, but if you see, it is because chi-square is also for association. And in case of ordinal, generally you go to this regression, and when you click this correlation matrix, here you will see this Kendall tau, okay? This one. So this is basically association where you treat one as a ordinal, another maybe as a binomial or a continuous, this one. So it says that at least one variable should be ordinal. Is it okay, Akash? Okay. So if it is okay, then we can go to the breakout room.
Yes, ma'am.
Okay, so
Recording rights सबको है.
we have given the recording rights to everyone. You guys can record. And I guess Anand is here today. Anand, can you open the breakout room?
Yes, ma'am.
So how was your experience? Yes, I think everyone is okay. Now I think everyone came because number is increasing now. So I want one thing to be rectified. What I said was regarding the Fisher exact test. Akash also inquired in between. So right now we looked up to the literature regarding Fisher exact tests, and classically they say that classically it started as 2 by 2 table, and because it basically it calculates the exact value because chi-square works on approximation, but this Fisher exact calculates exact value. So initially the SPSS and GEMOB, they were not giving the Fisher exact value for table more than 2 by 2. But now, even with n by n, you can go for Fisher exact test. So like I think who asked? One participant asked in between regarding the clubbing of category. And even if like after clubbing, if the cell frequency is less than 5, then also, even if it is less than 5 in n by n, you can go for the Fisher exact. Like you can see here, I have put this n by n, this hypertensive and this thing here. And this is, you can see it is the Fisher exact value is there now. Yes?
Ma'am, just I have a doubt. In Fisher
Yeah.
exact test as well, we will go for that expected cell count or an observed cell count.
In any, this again, Fisher exact, you don't go by the expected. Because you do, I mean, initially for assumption, definitely you have to check for chi-square. But if the expected cell count is less than 5, you will go for Fisher exact. Your
Okay,
question is like how this Fisher exact value is calculated.
No, ma'am. When to go for Fisher exact? Exactly at what
Oh.
where?
So exactly like, I think you people got confused with like 80% or more than 80% or something like that. Am I right?
Yes, ma'am. And that as well as that Yates correction. When to
Okay,
go for that?
Okay. So Yates correction is like initially when this Fisher exact was not there, that means initially, like I said, that Fisher exact option was there only for 2 by 2. So in case of this thing, when the value is less than 5, then you can go with this continuity correction, which I told you on Saturday. Like in this case, since you can see here, the cell count, expected cell count in these cells, like this is 2.82, this is 2, and this is 1. So let's say it is less than 5. Now you can see like because there are how many categories? 1, 2, 3. But generally so low, you can again classically if you see LERD, they say expected cell count in 80 more than 80% of the cells. They don't say in all cells. So classically you see that there are 1, 2, 3 and 4. 4 and 3. That means 12 cells are there in this particular example. So if you calculate the percentage of 3, so it will be like 25%. So again, yes, 3 is how much? 3 multiplied by 4. So 3 cell is 25%. So yes, if it is 3, that means in 80% it is in 75% of the cell more than 5 expected frequency. So in this case, you have got two options. Either you can, so classically, since Fisher exact option was not there, Dr. Nitin?
Yes, ma'am, you're audible, ma'am.
Okay. So classically, because
Hello, madam. This is not a 2 into 2 table, no? This is a 3 into 3 table, right?
this is 4 into 3. One,
But
two.
I think we should take Fisher extract means 2 into 2 table or examples only we should take. No?
That's what I'm telling Dr. Sumant. Like just before going to the breakout room, I have made a statement that Fisher exact should be applied for 2 by
Okay,
2.
for 2 and 2. Yes, yes, ma'am.
But again, then I looked up into the literature because when I applied this Fisher exact here in Jamovi, the value was coming, right?
Okay, okay.
So then I thought like maybe few years back till the like coding that Python and all, it was not available. So like SPSS and Jamovi, they were not able to give the value of this exact for more than 2 by 2. But now, since all those coding methods are available, so even the Jamovi and SPSS, now it can give you the value of Fisher exact in more than 2 by 2 table.
Okay, ma'am.
Is it
Okay.
clear? So
Very
the
clear, ma'am. Very
statement
clear.
which I made earlier, I just want to improve upon that.
Okay, ma'am.
That
Thank you,
Fisher
ma'am.
exact, now we cannot say, I mean, it should not be said that it can only be applied, means initially also the value was coming, but that was not through the traditional available software. But now even the traditional available software can give you the value of Fisher exact for more than 2 by 2 table. And since for more than 2 by 2 table, you have got two options. Either if you want to go on the basis of this probability, not on exact value, you can go with continuity correction, or you can apply the Fisher exact test also if you want exact value. Because
Okay,
this calculates the this continuity correction or Yates correction that takes the probability into account, whereas this Fisher exact gives you the exact value. So it is up to you. Either you can report this chi-square continuity correction for n by n table, or you can go with the Fisher exact also. Both can be done.
Okay, ma'am. Thank you, ma'am.
So Dr. Nitin, could I answer your question?
Yes, ma'am, understood, ma'am.
Okay, so
There's one more doubt.
Pardon?
Ma'am, there's one more doubt, ma'am.
Yeah.
When we were doing test of two proportions,
Mm-hmm.
there was a question as daily water intake across region, and the region they have mentioned as north versus south. But when we get other categories, we can transform that. But how to transform these nominal data? Or else we have to go to Excel sheet and just we have to filter it out.
Yes, Excel sheet or what you can. Yes, you can. The filter we can do it here also. Like I have not told you the option of filter here, but that's why we say that you should like do this in the coding, because in coding when you write that category in coding, then you can transform it here also. But if it is not, you can apply filter here. So you are right.
Can you
So
just show it once, ma'am?
yeah, sure. So which like can I have that question? Let me. Test of association. Let me see if it is here.
Proportional.
Test of two proportion. So the question was what? So you said
Water intake.
water intake. Daily water intake across region is the proportion of individual with the adequate water intake significantly different. Actually, north versus south. So in this case, what I think that okay, you are leaving the other subjects then. Ideally, it should not be there. This question, let's take, you can go to the frequency and then this is already there. So if I see the region is across north versus south. So I'll have to go to the data. No, let me see now. Filter.
Coded, non-coded होगा ना?
Let me see. Oh, is it not coded?
I don't think so. एक बार देख लीजिए.
एक सेकंड रुको.
1-2 का तो ज़्यादा आसान होता है.
That's what because we have imported. We took the responses in Google form.
टाइप करना पड़ेगा.
Just a sec. Okay.
टाइप करना पड़ेगा.
So since it is in this thing, we cannot do it here because for transformation.
नहीं, filter में टाइप करके करना पड़ेगा.
No, filter we can do, but transformation we cannot do. Filter, yes, we can do. Let me try it out. So I have to filter the north and south, or I have to do not select east and west. So I'll go to the filter, select there's a function which is like exclamation mark, not, and row. But I don't think we see because it identifies it with row, na, it will not take. So I think this question only that having this
We are reducing this.
This Dr. Nitin on Jamovi, neither this transformation is possible. So I think this question you need go like you were saying, we need to go back to Excel, and it's better that we give code there like 1, 2, 3, 4 to various region, or give us some time probably after this t-test. Probably Dr. Shamshad is looking up if we can solve this, then probably in the next breakout room, before that next breakout room, we'll be able to tell this. Is it okay?
Yes, ma'am. Yes, ma'am.
Because filter also we can go by this row only. Let us, let me check this. In the meantime, we have noted down your question, and we will start with the independent sample t-test. Before that, any other query which I can tell you right now? Yes, there was another thing which I wanted to tell regarding when Akash asked regarding this Kendall tau. So remember, for Kendall tau, at least one of the variables should be inordinal in nature. So if you see the value of Kendall tau through this chi-square, so this was the correlation matrix when we applied through the association, through the correlation, because I told you that this Kendall tau appears in the correlation, although we have not told you the correlation like Pearson correlation and Spearman correlation, but I guess many of you have got some idea regarding correlation. So if you go, because association, see all these correlation coefficient and all, that is also like an effect size only. So the effect size, if you are going for chi-square test, and this, if I go with this frequency test of association, and I apply the same hypertension and diabetes. So I go with this hypertension and then diabetes. And so this is the hypertension and diabetes. And if I click on this Kendall tau. So see the value of Kendall tau, it is 0.16 and 0.03. So even if you calculate your effect size through Kendall tau here in chi-square, or you go to the option of correlation. If I go to the correlation, so remember this value is how much? This is 0.16 and p value is 0.03. So if I go to this correlation matrix and take these two variables, same hypertension. So this I can give this hypertension grade and diabetes status and diabetes status. And if you click on this instead of Pearson, if I click on this Kendall tau, you can see this 0.16. So this is the same value. This one, and this one. Is it okay? So am I making myself clear what I want to convey? I don't know. There is a complete silence. Someone can say something yes or no, even if you
Yes,
say
ma'am.
it's well,
Yes.
okay. Okay, thank you. So then I'll go to the independent sample.